Hello everyone, welcome to Prince on Air, and this is the solution series of chapter 1, that is solid state. Okay, in this particular videos we will discuss about the NCRT solutions of back exercise questions. Okay, so here without wasting any time we will start the video, because that video will not be so much lengthy, and here we will just discuss about the solutions of back exercise. Okay, and some questions we have discussed already in the particular lectures also, and some of the solution I will provide here also. Okay, so let's start. First question is define amorphous. Define the term amorphous and give you few examples of amorphous solids. So tell me the answer here. Try to solve that question yourself first. Amorphous solids are what type of solids? Okay. So see, amorphous solids. These are the solids in which the particles are randomly distributed, or you can say placed, okay, without any, you can say, the particular geometric shape. Okay, so here no regular arrangement is there. Okay, you can say no regular arrangement of particles is there. Okay, clear? So that is the particular answer here for the amorphous term. So give few examples of amorphous solid. Yeah, that particular examples are plastics. Okay, polymer you can take here. That is glass. Okay, rubber. So these are the particular examples of amorphous solids. Okay, so let's start next part question. Which makes the glass different from the solid, such as quartz? Under what condition could quartz be converted into glass? So simple question is there. Okay, some questions the answer I will provide you, and some questions we have already discussed, and that answer I will just recommend you to watch that particular lecture. Okay, so what makes glass different from the solid such as quartz? So glass, okay, glass is an amorphous solid, where quartz is a crystalline. It is a crystalline solid. Okay, it is a crystalline solid. So to convert glass into quartz, there will be firstly heating, then cooling. Okay, that process is known as annealing. Okay, so firstly cool that glass, and then firstly heat that glass, then cool that, and in that way, particularly by changing the temperature conditions, the glass will convert into quartz. Okay, so under what condition could the quartz be converted into glass? By heating and then cooling. Okay, so that will be the answer here. Clear? Now next is classify each of the following solid as a ionic, metallic, molecular. It is molecular, network or covalent, and also for the amorphous. So first one is tetraphosphorus dicoxide. Yeah, tell me which type of this molecule is, or which type of this solid is. That answer I've given to you already. First, it is of molecular. Okay, phosphorus dioxide is the molecular solid. Okay, so next one is ammonium phosphate. Okay, tell me the ammonium phosphate. Ammonium phosphate. Second, ammonium phosphate. It is an ionic. Okay, it is ionic. Next one, third, SiC. SiC. It is a covalent. Okay, or you can say network solids. Next one is I2. I2 is molecular. Okay, next one is P4. Yes, P4. Tell me P4. It is also molecular. Okay, it is also molecular. Graphite, obviously. Graphite, 7th. Okay, it is of 7th here. So graphite is covalent. Okay, brass, it is metallic. Rubidium, metallic. Okay, lithium bromide. Tell me, lithium bromide, it will be ionic. Silicon, it will be covalent. Okay, so that are the answers. Okay, next one is, what is meant by the term coordination number? So just define that term coordination number first. Yeah, that is the number of nearest neighbors atoms. Okay, so you can say that particles just nearest neighbor. Okay, these are the number of particles which are nearest neighbor. Clear? So what is the coordination number of atom in cubic closed packed structure? Cubic closed packed structure, in cubic closed packed structure, and in body centered cubic structures. Okay, so to identify that answer in detail, just you have to watch that previous lectures, and here I just give you that answer. For this it will be 12. You can see there. Okay, and in that case, if you will see this particle, it is touching 12 particles, so it is a cubic closed packed structure. And similarly for body centered cubic structure, it will touch, if I am having that this one is cube, and in the room, if I am putting that particle here, okay, so that particular particle that at the center of the body, it will touch front, back, left, right, up, down. So here in that case its coordination number will comes out to be, in that case you can see that if I am having that particle, it will touch the 8 corners also. Okay, so just 8 corners, not we are in that case we were just considering the FCC. So not in FCC, body centered, the particles are at the center of the body and it will touch the corners. Okay, 8 corners. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it comes out to be 8. Okay, its coordination will comes out to be 8 here. So next one is, how can you determine the atomic mass of an unknown metal if you know its density and dimensions of its unit cell? Explain your answer. Yeah. So how can you determine the atomic mass of an unknown metal? how 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 yeah. So here you can just identify by this method, like okay, all dimensions are known to you. So density is equals to mass over volume. Okay, we have to calculate the atomic mass, that we have already discussed. Density we can rewrite it as d, mass me, and volume v. So all of you know that in the cubic structure, that units are considered to be as a cubic in shape. So its length will be, edge length will be a. We are considering that edge length is equals to a. That edge length considered to be a. Okay, so here what we can do, the volume will be aq. Okay, here now we have to calculate the mass. Mass will comes out to be z into mass of single particle. Okay, z is the number of particles, and mass is the mass of single particle here. Okay, okay, so now we have to calculate the mass of particle. It will comes out to be molar mass, which is m upon Avogadro's constant. So now me will be z into molar mass upon Na. So if you will put the value of me here, so density will comes out to be m z m upon Na into aq. Okay, so here we have to calculate the molar mass, or you can say atomic mass. It will comes out to be m is equals to d a cube Na upon z. Okay, so that will be the answer here. Clear? Next one. Stability of a crystal is reflected in the magnitude of the melting point. Comment. Collect the melting point of solids, points of solid water, ethyl alcohol, ethyl ether, diethyl ether, and methane from a data book. What can you say about the intermolecular forces between these molecules? Okay, so just I will give you that hint. You have to solve that question yourself. I will give you that comment on the stability of crystal. Okay, means which is the reflected by the magnitude of melting point. So if melting point of crystal is high, if the melting point of crystal is high, if the melting point of crystal is high, then you can say the force of attraction is high. Force of attraction is high, means we can say that so crystals density is high, and also more stability of the crystal. So you can say the stability of a crystal is reflected in magnitude of its melting point. How? Because if the you can say the melting point is high, then force of attraction will be high, and in that case the intermolecular forces of attraction will be high. In that case, that we can say that crystal will be more stable. Okay, so just we have to calculate the melting point of water, solid water, ethyl alcohol, diethyl ether, and methane, and from that data you have to just tell which will have more stability, and what can you say about the intermolecular forces between in these molecules. In that way, those are having high melting point, they will have high intermolecular force of attraction. That data I will tell you by orally, just you have to note it down. Okay, so the data is for water is 273 Kelvin, ethyl alcohol is 155.7. I can explain it all. Okay, For water it is 273 Kelvin. Then ethyl alcohol, then diethyl ether, then methane. Okay, so ethyl alcohol is 155.7, diethyl ether is 156.8, methane is 90.5. Okay, now tell me which one will have high melting point, or you can say means that melting point we will got. Okay, then which one will have high intermolecular forces of attraction? Obviously water will have. Okay, among these you can tell me in that will be second number is ethyl ether, then ethyl alcohol, and then methane. Okay, so why water is having high intermolecular forces of attraction? Which type of intermolecular forces of attraction is there in water? In water, that is hydrogen bonding. Okay, so which is strong dipole interaction. Okay, clear? So next is, how will you distinguish between the following pairs of the terms? That we have already discussed. Okay, that we have already discussed in the previous lectures. You can see that lectures once again, and I just give you that hint how to give that answers. Okay, the hexagonal close packing and cubic close packing. Hexagonal close packing and cubic close packing. That difference between these two you have to tell. Okay, so what will be the difference here? Hexagonal close packing is AB type, and the cubic close packing is ABC type of close packing. Okay, in 3D dimensions. Remember that. Okay, clear? That you can see from that lecture. Clear? Close packing lecture. Next one is crystal, lattice, and unit cell. That also we have discussed there. Okay, and tetrahedral void and octahedral void, that also we have explained in that particular lecture. In the one particular lecture you can see there all answers. Okay, that we have already discussed there. Okay, that's why I am not explaining here. Clear? So shall we move now? Yeah, next one is, how many lattice points are there in one unit cell of each of the following lattices? Yes, lattice points was they were asking. Okay, lattice points, not number of particles. So we both you can tell. Okay, so first one is for face centered cubic. Face centered cubic. Face centered cubic is that particles in which the particles are present at corners and also at the center of each face. Okay, so in this case the number of particles you can count 8 corners and 6 faces, so it will comes out to be, wait 8 corners 6 faces, that will be 14. Okay, that will be 14 here, number of you can say the lattice points. And for face centered tetragonal it will also be same. For body centered it will be particles are present at corners and also at the center of the body, so it will be 9. Okay, 8 corners and at 1 centers. Now if you want to give the contributions, okay, total particles contribution, here 8 particles are having 1/8 contribution plus, and 6 particles are having 1/2 contribution, so 1 plus 3, total particles will be 4 here. Okay, particles, number of particles. Here 8 particles which are at corner are having 1/8 contribution, plus at body center it is having 1, so it will be 2. That all parts we have discussed in the detail. Okay, next is, explain the basis of similarities and differences between metallic and ionic solids. Okay, firstly we will discuss about the similarities. Okay, similarities between the metallic and ionic solids. So metallic and ionic. Metallic solids are also conductor, can conduct electricity. Okay, these can also conduct electricity, no doubt. In liquid state, molten state, or in aqueous state, they can conduct electricity, but they can conduct. Okay, so they are also having electrostatic force of attraction. Okay, no doubt metallic bond is there, which is also the type of electrostatic forces of attraction here, and here it is also electrostatic force of attraction. So that basically that are the similarities. Metallic solids are also hard but soft also. Okay, it may be hard, it may be soft, but ionic solids will hard. Clear? And these are also hard and brittle. These are also hard and brittle. Okay, clear? So these are the similarities. Now differences is that ionic solids or metallic solids. Okay, that ionic solids that conduct electricity only in molten state. Okay, conduct only in molten state, but metallic conductors can conduct electricity in the solid state also. Okay, so that is the main difference between these two. Okay, clear? And in that case, metallic solids, the conductivity is due to free electrons. Here in ionic crystals, the conductivity is due to free ions. Okay, so that is the main second difference between them. Okay, so next is ionic solids are hard and brittle. That we have to explain here. Ionic solids are hard and brittle because due to hardness is due to strong electrostatic force of attraction. Okay, due to strong electrostatic force of attraction. And brittle is, why they are brittle? Due to non-directional force of attraction between them. Okay, so you can say that particle is having any charge, and here it is of opposite charge. Like here it is sodium, it is chloride, and front side also chloride, back side also chloride. So sodium will have similar type of bonds of forces of attraction between these all chloride ions. Okay, so it will not have any particular directional nature. Okay, so that's why no directional nature, that's why it is a brittle in nature. Next is calculate the efficiency of packing in case of metal crystal for simple cubic and body centered cubic and face centered cubic. Okay, so these all derivations we have discussed in the lecture number, I think so 6th or 7th. Okay, 6th or 7th lecture we have discussed all that. I think so the 6th lecture is there. Okay, so you can check it once. So that topic name is packing efficiency, and in that particular lecture we have discussed all that packing efficiencies. Okay, if I am going to explain all that parts, that will take so much time here, because in that particular lecture we have discussed in detail. Okay, so you can see that lectures, and that all the derivations are there, and in that lecture you have to write all the derivation in this particular question. Okay, clear? Yeah, in that can you tell me that which is having more efficiency? That is face centered. Second number is body centered, and simple cubic is having very less efficiency. Okay, clear now? So I just suggesting you only two questions. You have for those two questions you have to follow the previous lectures. Okay, and all other questions which are taking less time, that I have already explained you, and even also provided the answers. So that particular series only for you to just give you help to solve the back exercise questions also. Okay, So thanks for watching this video, and that is the end of this lecture. So stay safe, stay at home, and keep motivated. Okay, so thanks for watching this video. Okay, bye.